Good morning or good afternoon, and welcome to lesson 9 of module 1. Today you're going to be learning about how to add and subtract numbers that are written in scientific notation. First, we're going to review a little bit how a number is correctly written in scientific notation, and then we'll get into our new learning. Okay, let's go ahead and begin. All right, to build some background, we're going to be checking to see if these numbers are correctly written in scientific notation. A few things you need to know about scientific notation. It needs to be times 10 to a power. Okay? Our leading digit, that number that's in front of that times 10 to the power, needs to be greater than 1. Our leading digit also needs to be less than 10, so it's a number between 1 and 10, and that's how we write it in scientific notation. So starting with exercise 1. Is this in scientific notation? Well, we do have times 10 to the something. Our leading digit, is it greater than 1? Greater than or equal to 1? I'll actually change that. Yes, it is 1.908. That works. And is our leading digit less than 10? Yeah, it's 1. So this is written in scientific notation. Exercise 2. Let's look at it. Oops. We have 0.325. So we do have times 10 to the negative second, so that's good. Looking at our leading digit, is it greater than or equal to 1? No, this is less than 1. So no, this is not in scientific notation. And the reason why, our leading digit is less than 1. Has to be in between 1 and 10. Okay. Exercise 3. Let's look at this one. We have times 10 to the 32nd power. And here's our leading digit. Does everything look good here? Yeah, this looks like it is correctly written in scientific notation. No issues there. Exercise 4. Let's look at this one. We have plus 10 to the 7th. Is that correct? No, we need times 10 to the second. So no, this is not written in scientific notation. We need it to say times 10, not plus 10. Okay. Exercise 5. We have times 5 to the 8th. We also have 18 as our leading digit. So no, this is not in scientific notation either. We need times 10, not times 5. And additionally, our leading digit is greater than 10. And we need this leading digit to be less than 10. Last one down here, we have times 10 to the negative 11th. That works. And we have 8. Now, there's no decimal point here, but where would the decimal point go if it was here? Well, it would go right beyond that 8. It would be 8.0. I want you to know that these two things are the exact same. 8 times 10 to the negative 11th is the same as 8.0 times 10 to the negative 11th. You don't have to show that decimal because there's no number that comes after. It's just going to be zeros forever. So this is written in scientific notation. We have our times 10. We have a leading digit in between 1 and 10. So this one is written correctly. Okay. Now before we move on, I do want to go over one more thing with you. And we're going to focus on this one to do it. Today you're going to have to be able to recognize, is this number written in scientific notation? As a part of our lesson, it'll be like your last step. And then if it's not, so if it's like this one and it's not written in scientific notation, you're going to have to learn how to put it in scientific notation. So I have 0.325 times 10 to the negative second. Well, this is not in scientific notation because the leading digit is less than 1. And so we need to, my sign right here is wrong. Less than 1. We need to put it in scientific notation by making the leading digit greater than or equal to 1. So to do that, I want my leading digit to go right here. I want it to say 3.25 times 10 to the something. Okay? So that's the first thing I do. I identify where do I want my leading digit to be. I want it to be right there. Well, if I did that, then I'm moving this one space back. Okay? So how is that going to change my exponent? Is it going to get bigger or smaller by one space? Let's think about it for a second. Well, if we made this number bigger, then we have to make this number smaller. So what's smaller than -2? What's one number smaller than -2? It is -3. Okay? And I'll show you what these numbers look like when we actually write them out, not in scientific notation. If we were going to move this decimal back 2 spaces, it would be right here, 2 spaces. Okay? We just moved it from right here back 2 spaces. And if we were going to move this one back 3 spaces, it would be in the same spot. Because right now it's right here and we're going back 1, 2, 3. So essentially we're writing the same number, we're just moving the decimal point a place. And so if we ever move the decimal point a place, we have to move change our exponent as well. And we'll practice this today, so don't worry. I just wanted to give you a little preview before we get into it. Okay? Let's go ahead and move to the next slide. All right. It says the table below shows the debt of 3 most populous states and the 3 least populous states. What is the sum of the debts for the 3 most populous states? So we are going to be adding numbers in scientific notation today. So we are going to be adding 3 numbers up here, the 3 most populous states. So that would be California, New York, and Texas. And we're going to be adding these debts up. Okay? The first thing I want to do is I want to rewrite those debts in scientific notation. So the first one, 4070000 forever. My leading digit there is going to be 4. And I'm going to put 0.07. I do not need the rest of those zeros because it's not going to change my number. I'm doing this times 10 to the, well, there's going back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Times 10 to the 11th. Okay. Second one. So we're going to be adding that with our next number. 3.37 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 10 to the 11th. Plus this last one, decimal point's going to go in between the 2 and the 6. 2.76 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 again. Okay, and now we're going to add these together. Now this one is pretty easy because they all have the same exponent. So if they all have the same exponent, we can just go ahead and add. We use our exponent rules. So the first thing I'm going to do is add my numbers together, and then I'm going to work with my exponents. So my numbers here are 4.07, 3.37, and 2.76. So add those off to the side. Okay. And I'm just going to do it in my calculator, just to be sure. I get 10.2. Okay. And from there, I'm keeping the same exponents each time, so I'm not doing anything. Okay, I'm just going to keep the exponents that I have for my scientific notation part. So my answer here is going to be 10.2 times 10 to the 11th. Okay, now looking at that answer, The last step here is to check, is that written in scientific notation? Well, it is times 10 to the something, but look at our leading digit. It is too big. So we have to move our leading digit so that the exponent is right there. Okay? So I made my number one space smaller, one place value smaller. That means I need to make my exponent one place value bigger. You just do the opposite. Okay? And so this would be my final answer. The sum of these three most populous states is 1.02 times 10 to the 12th power. Okay? And I could actually write that number out if I wanted to. I would just have to move my decimal 12 spaces. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is the actual number of those states added together, the debt. Okay? This is my final answer. And that's what we're going to be doing today. Let's go ahead and recap what we just did in our new learning page, and then we'll get into some practice. All right, here's our new learning today of how to add numbers in scientific notation. The first thing we have to do is write our numbers in scientific notation. So if I'm adding these two numbers down below, I would go 6.02 times 10 to the third. Moved it 3 spaces, 1, 2, 3, plus 3.14 times 10 to the, this is the second power. Okay, so I write them in scientific notation. The next thing I have to do, we did not have to do this on the last example, but we might have to do this today, is make sure that they have the same exponent. We cannot add them until they have the same exponent. So right now this one is 10 to the third, and this one is 10 to the second. I'm just going to quickly make this one 10 to the third. So if I want to make this one space bigger, I have to make this one space smaller. Okay? So this becomes 0.314 times 10 to the third. And now they have the same exponent. Okay? So I made them have the same exponent. Next step is to add the numbers together. So I have 6.02 and 0.314. If I do that on my calculator, 6.02 plus 0.314, that equals 6.334 times 10 to the, what is the number I had it? Let's see, exponent 10 to the third. I added my numbers together. The last thing I want to do is check to make sure my answer is correctly written in scientific notation. Is this correctly written in scientific notation? Well, I have times 10 to the something, and my leading digit is between 1 and 10, so this is correct. This will be my final answer. So we're going to follow these steps today throughout. I have this little thing shown on my screen the entire time. You don't have this, but just look at my screen if you need to, and then I'll share this with you in Google Classroom at the end of the class so that you can reference it if you need. It's just a little example, and it's actually the example I just showed you. Okay, let's go ahead and move on to some practice. All right, we're using the same table. This time we're doing the sum of the 3 least populous states. The first thing we need to do, like we just learned on our last slide, is write them in scientific notation. So please write those 3 numbers out in scientific notation. Take a moment to do that. Here's what you should have written. 4 times 10 to the 9th plus 4 times 10 to the 9th plus 2 times 10 to the 9th. Okay, and here's why our decimal point is going right here for all of these. Moving 3, 6, 9, 3, 6, 9, 3, 6, 9 spaces. I did not put 4.0 or 2.0 because it's not going to change anything. Okay. From there, we want to add these up, but we have to make sure, do we have the same exponent first? 10 to the ninth, 10 to the ninth, 10 to the ninth. We have the same exponent, so we are good to add. Okay, so the first numbers we're going to add are our whole numbers. 4 plus 4 plus 2. 4 plus 4 is 8, plus 2 is 10. And then we're just going to keep that exponent that we already have times 10 to the ninth. Last step. Are we correctly written in scientific notation? Well, we have times 10 to the ninth, but our leading digit is too big. Right now our decimal point is right here. We want it to be in between the 1 and the 0. So if we made my number smaller, went from 10 to 1, we're going to make our exponent bigger. This becomes 9, 10. Okay? And if you wanted to rewrite this so it's a little bit smaller, simplified, it would just be 1 times 10 to the 10th. That means the same thing. And that is our answer in scientific notation, 1 times 10 to the 10th. Give you a second to write that down, and I'm going to show you what that number actually looks like. You don't have to write this part. This number would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the sum of all those debts of those least populous states. Okay, make sure you have it down, and we'll move forward to the next example. All right, here's where we do a little bit of subtraction. It says, how much larger is the combined debt of the 3 most populous states than that of the 3 least populous states? Express your answer in scientific notation. So we need to get our answers from the first few slides. I'll just tell you what they were. The first answer of that, the 3 most populous states, was 1.02 times 10 to the 12th. And our last one, the 3 least, was 1 times 10 to the 10th. Okay. How much larger is this than this? So we want to find the difference. So we are subtracting. Okay, we're going to be subtracting these numbers. So the first thing we need to do is make sure they have the same exponent. And they don't. This one is 10 to the 12th. This one is 10 to the 10th. Okay. Now it's up to you which one you want to change. It really does not matter. Sometimes it's going to be easier to change one than the other. But it's really, like I said, it's up to you. I'm going to change this first one. I want this to just say 10 to the 10th. Okay? So if I made this 2 spaces, 2 numbers smaller, I'm going to be making this 2 spaces bigger. It's going to be 2 spaces bigger. It's going to actually be 102 times 10 to the 10th minus 1 times 10 to the 10th. Okay? From there, I subtract my actual numbers. 102, take away 1, that is 101. Okay, and then I'm just going to keep the same base exponent thing that I had before, so it'll be times 10 to the 10th, right? Last step here is to check and see, is this correctly written in scientific notation? Well, right now, it is not. Obviously, this is a way bigger leading digit than I want it to be. That's 101. I want my decimal to move to be right here. Okay, I want it to move 2 spaces back, so I want it to get 2 spaces smaller. So that means this has to get 2 spaces bigger. So this is 10 to the 12th. So this would be my final answer. The difference between these two numbers is 1.01 times 10 to the 12th. Alright, please make sure you have that down before we move on. Alright, we're going to continue with the same table. This time we're going to talk about the populations over here instead of the debts. It says, what is the sum, so we're adding, of the population of the 3 most populous states? So we're adding these 3 numbers right here. Right, the first thing I want you to do is please write them in scientific notation down below. Okay, please check your work with my work. Those are the numbers you should have written. They're all times 10 to the 7th, and it's just 3.8, 1.9, and 2.6. Okay, second thing we need to do. Can we add these? Do they have the same exponent? They do. We don't need to change anything, so we can add them just how they are. So we're going to add our numbers up. 3.8, get it in your calculator, plus 1.9, plus 2.6. This comes out to be 8.3. And then we keep that same number we were multiplying it by, times 10 to the 7th. Last step is to check and see, is our number written in scientific notation? I have times 10 to the 7th, and I look at my leading digit. Is it between 1 and 10? It is. So this is correctly written already. Okay. Let me know if you have any questions before we move on. Here it says, what is the sum of the population of the 3 least populous states? So these 3 states, please write these numbers in scientific notation and then add them up. Take a couple minutes to do this, pause the video, and then come back, press play, and check your work once you have figured out your final answer. I want you to get to your final answer before you check. Okay? So pause right now. All right, after you have solved, you can check with me. These are the numbers I've written in scientific notation. I check they all have the same exponent, so I can just go ahead and add these numbers up together. What I get is 18.92 times 10 to the 5th. From there, I need to make sure my number is written in scientific notation. It is not. I want this decimal to be 1 space back. So it makes my number 1 place value smaller. So I need to make my exponent 1 number bigger. I do the opposite, right? I made my number smaller, make my exponent bigger. And then we moved 1 space for my decimal, so I'm moving 1 number for my exponent. This is the final answer here. Okay? Let's go ahead and keep going. Moving on to number 8B. 8C, sorry, exercise 8C. All right, it says, approximately how many times greater is the total population of California, New York, and Texas compared to total population of North Dakota, Vermont, and Wyoming? So essentially, we're going to be dividing these numbers. This is review, okay? But we're going to take these numbers that we've already written in scientific notation and then divide them. So let's go back and write down our answers from the last couple of questions and then find this answer. All right, I've gone ahead and I've written our 2 answers right here below. So these 3 states, when we added them together, this is the number we got. And these 3 states, when we added these populations together, this is the number we got. And we're trying to figure out how many times greater is that green than the yellow. So we're going to divide. So I've already written my division symbol right here. We are dividing these 2. Now, when we divide like regular. And then we, if we have the same base, we just subtract our exponents. So the first thing we're going to do is we're just going to divide these numbers normally. 8.3 in your calculator divided by 1.892. I get a very big number. It is 4.386, and I'm just going to round it off to 9. I'm just going to stop right there after 4 places, okay? The next thing we're going to do is we are going to figure out our exponent. Well, if we have the same base, to simplify that or divide those, we just subtract. So what is 7 take away 6? 7 take away 6 is 1, so it's going to be times 10 to the first power. Okay? And then the last thing I want to do is I want to check and see, is this number written in scientific notation? Well, I have my times 10 to the something. Okay? And then I look, is my leading digit between 1 and 10? It is. So this is correctly written in scientific notation, but it doesn't ask me to leave my answer in scientific notation like it did on the other ones. Could we write this out as just a regular number? Yeah. What would this be as just a full number, not in scientific notation? Well, 10 to the first power, that means that we just really need to move our decimal one space to the right. This is the same as 43.869. So how many times greater is the population? It's about 43.869 times greater. Okay, make sure you have it down. Let me know if you have any questions. We are actually going to skip this slide. We're not going to do this one. We're just going to go ahead and review our learning on the next slide. All right, here is our lesson summary. When you are adding or subtracting in scientific notation, these are your steps. The first thing you need to do is write your numbers in scientific notation. You'll see off to the side right here, these numbers are written in scientific notation. The second thing you need to do is you need to make sure they have the same exponent. Sometimes they will, sometimes they won't. This was 10 to the 3, this was 10 to the 2, so this person made them both 10 to the 3. Okay? From there, you add your numbers together. So you add the whole numbers. And then you keep the same base that you had before. And then the last and final step is to make sure your number is correctly written in scientific notation. If it's not, you need to change it so it is. If it is, then you're good. And one thing I want to remind you of, let's see, if I wrote 13.2 times 10 to the second, if I wanted to put this in scientific notation, I would have to make this one space smaller, right? So I'd make this one number bigger. Just do the opposite. If I had 0.132 10 to the fifth, and I wanted to write this in scientific notation, I would make this one space bigger, right? And so I would make this one number smaller. Okay, you'll always do the opposite. If you need to write that down, write that down. Otherwise, we're going to go ahead and go over the exit ticket real quick. All right, here is your lesson exit ticket. Number 1, the approximate total surface area of Earth is 5.1 times 10 to the 8th. All the salt water on Earth has an approximate surface area of this big number here. And all the fresh water, that. How much of Earth's surface is covered by water, including both salt and fresh water? So essentially, here's what you're doing. You're going to take this number, which is the total surface area of Earth, 5.1 times 10 to the 8th, and you're going to subtract these two numbers, but you have to add them together first. 352,000,000 plus 9 times 10 to the 6th. Okay? Now, I'm breaking this down for you in Galileo. The first thing I'm going to have you do is write that in scientific notation. Then you're going to find the sum. And then you're going to find the difference between these. So it's actually going to be 3 questions for question number 1. Okay? Number 2 goes along with it. I'm probably not going to put that in there, but it'll just basically say how much of Earth's surface is covered by land. It'll be your answer to this 3rd question where you find the difference. The last one is how many times greater is the amount of Earth's surface that is covered by water compared to the amount of Earth's surface that is covered by land. You're going to be taking this number right here and dividing it by this sum. All right? And again, I'll walk you through it and break it down in Galileo for you into smaller questions. Remember, if you're not ready for this, rewatch the video, go back through your notes, practice a little bit more before you move on to it. Okay? That is the end of this lesson.